Today we're going to look at LeetCode 1323, the maximum 69 number. So the problem states, given a positive integer num consisting of only digits 6 and 9, we want to return the maximum number we can get by changing at most one digit. So we can move 6 to a 9, or we can move 9 to a 6. Okay, let's check constraints. And we can see here our input's going to be pretty clean. We're only given 6s or 9s. That's nice. And the range is pretty small as well, so we don't really need to worry too much about timing or complexity there. That's good. Okay, so let's take a look here. Right away I'm kind of seeing just an iteration problem. It looks like to create the maximum, the largest number, it looks like we want to find the biggest 6 here, the first 6, and just change that to a 9, something along those lines. So the most straightforward way to do this would be just converting this to a string, and then we can iterate over it and find the first instance of a 6 and change that to a 9, convert it back to an int, and return it. So in an interview, I'd make sure to explain that you could do this just given num as an int. If they want you to, you could do it without using any conversions or anything like that. But the code for that would be, it'd definitely be more dirty. So you could basically, you can use some modulo magic and kind of iterate through, have I start at 0 and iterate over each of the decimal places and use math.pow to, math.pow combined with a modulo to kind of get access to each of the digits and check for the first 6. You could do that, but today we're just going to do the cleaner string conversion back to an int conversion method here. So let's jump in. I'm just going to paste in our function body here, and let's set this up, and let's just return a dummy value here. We'll change that later, and let's set up some tests. So we'll just make an int slice, and let's use the same values they're giving us here. So 9669, 9996, and all 9s. Okay, and let's build out a runner. So we'll say for, we don't care about the index. So for value in tests, we want to print out our function given that value. Okay, so we're just going to iterate through our tests, and we're going to print the result of our function called with the current test value. So let's just do a test run on that. We should get 3 negative 1s. Yep. So we can see that's looping through our test cases. Okay, so let's jump into our function body now and get to work. So the first thing, we kind of talked about it earlier, we want to convert this to a string to be easier to work with. So Go has the string conv library here, and we're looking for an integer to a string function here, so the I to A, and we can just see an example here. Basically, we have an integer, and we can allocate a new string just by calling this function on the integer. So let's do that here. We'll say num as string, and we're going to set that equal to string conv dot I to A, and we'll pass in num, and let's import string conv. Okay, and that's just giving us a compiler error. It's declared but not used. That's okay. We'll use it in a bit here. So now we have a string. So there's two ways we can do it. We can either, iterate through the, we can either iterate through and say if the character is, 6, replace that with a 9. We can do that, but Go has something nicer, and we can do this just in a quick one-liner here. So if we're in the strings package here, we can see that there's the replace function. So replace returns a copy of the string with the first non-overlapping instance of old being replaced by new. So given a string s, we can look for old, and we can replace it with new, and we can repeat that n times. In our case, we just want to do this once. That's the problem. That's the problem statement there. So let's do this. We will say max as string, and we can just say strings dot replace. Yep. And that imports it for us there. So we can do strings.replace, and we're going to say num as string, and we're looking for 6, and we want to replace it with 9, and we want to do it once. Okay. And there's the declared but not used error. That's fine. Okay, so now the last thing we want to do is just convert this back to an int. So we can say max as int, and we're going to be back in the stringconf library package. Let's see, we're looking for string to int. Yep, so we can see a to I is what we're looking for here, and given a string, we can call this function, and that'll give us a string and an error. We don't care about the error. Our input is going to be valid just because this is an easy problem. It's a basic problem. So we can just ignore that. But we'll call a to I. Let me jump back into them here. A to I, and we're going to give it our string. So max as string. And it doesn't like that. Yep. So we just need to worry about the error here. I'll take care of that. And let's return our integer finally. Okay. So this function does return an error, but again, we don't need to worry about that. Our input's already clean. It's already good. We're not going to have bad input here. And we just return that int. Okay, so let's try running this here, and let's compare the results. So we get 9969, yep, all nines and all nines. So looks good. Let's bring our function back in, and let's run it. So again, the process we're going through here, we're converting our integer to a string. We're just calling a quick replace on that string, and we're finding the first 6 and just replacing it with a 9, and we convert back to an int, and we return that int. And that was accepted, and let's submit. And yep, so we can see that succeeded, and we had 0 milliseconds runtime, 2 megabytes of space used up. Okay, so let's talk complexities here. Complexity, so first of all, we're doing, the real piece of work we're doing right here is strings.replace. I to A, we can just kind of assume that's constant. A to I, we can just assume that's constant. This is constant work being done here too. So the real work being done here is that strings.replace, and that's kind of equivalent to if you just think about a for, kind of a for with do constant work in the middle here, which is just on. So this strings.replace call, worst case is going to be on, right? Worst case, you know, given 999, we're going to go through, hit each of these, not a 6, not a 6, not a 6, not a 6. So that's on work right there. That's worst case. So the time complexity is just on. And if we think about the space complexity, we are allocating some memory. We're doing num as string, max as string, and max as int. But these are constant allocations. It's not like we might do it n times, we might do it m times. It's nothing like that. These are constant. So this is just O of 1 space complexity. And if that doesn't make sense to you, even though we're allocating these, I encourage you to do some quick studying on space complexity. So again, the complexities here are, time complexity is just O of n, and the space complexity is constant, or O of 1. And that is LeetCode 1323.